Hello and welcome to May I AI. My name is Alexander Recevaik and I'm currently enrolled in a Master's in Management.
My name is Mustafa Al-Hayani and I have a Master's in Informatics with a focus on AI.
And we're both part of TUM AI, whose mission is to make AI accessible to everyone. This podcast is part of the AI Academy, a series of workshops hosted by TUM AI at the Technical University of Munich. This week we have Accenture with AI manufacturing. So, before we dive into the topic of AI in manufacturing, let's clear up the misconception between automation and artificial intelligence. Can you explain the difference?
Yeah, so automation and artificial intelligence are words that are usually used interchangeably. And of course, AI can be used to automate things and automation can involve AI. But AI is what we know of using general intelligence, right? It's using machine learning models and so on and so forth. So we talked about that before. Automation is the process of, automating different tasks, right? You have a series of tasks that you want to run. Let's say everyone runs right behind the other, and automation is just make sure that these run sequentially or in parallel if it is needed.
So AI can help with automation and we can use AI in automation, but if something is automated doesn't mean that it has an AI in it.
Yeah, so for example, we can look at, Japan has like these robots that make eggs for you or pancakes for you. This is automated but not using AI. The way it works is that the robot knows exactly a series of moves that it needs to do in series, and it assumes that with every starting movement that whatever is supposed to be done beforehand is already complete. But there is no AI in making sure it works. So, for example, if the pan doesn't exist anymore, it will still keep doing the same exact moves and it will burn everything.
Okay, so which kind of AI in manufacturing exists? Which are like the main topics and fields?
Well, we're not going to do like an exhaustive list, but we can look at like a series of options. For example, logistics, robotics, and quality control.
Let's stay with the topic of robotics for now. So, which kind of AI is involved in robotics?
Well, we can look at a very famous example that people know about. It's like the Boston Dynamics robot, right? And this robot has a lot of AI built into it. It has a camera to look at everything. It has some sensors. You can use LiDARs on it. And you can use all of these information to tell stuff to the robot. Now, of course, Boston Dynamics is controlled by a human, but you can also see how you can use the vision to decide where all the obstacles are, and then the robot can decide what to do afterwards.
So you're saying that the AI helps the robot understand the environment around it. But is the AI actually like physically controlling it? Is the AI telling the robot, hey, you need to move this motor by this much and like apply this force there?
Well, there are the two ways of doing it. There is this one way, and then there is a way of using control theory. And control theory is more sort of. It has mathematical background, and it's more dependent on, let's say. Where it comes to AI, you can use AI to tell the robot to move which motors, but of course the way AI works is that you need to train it, and then it becomes a bit too random and non-deterministic, which means you cannot heavily depend on it. So most robotic environments that you know of probably use AI to decide what the action is, but uses robotics and control theory to actually do that action.
So the AI, we can sort of think of it being the brain of the robot.
That is true, yes.
So the AI is the brain. So what does this brain do? Like you said it has a camera. It possibly also has a LiDAR sensor. Which kind of models are working there behind the scenes?
Well, we just talked about vision transformers, for example, and
that was last week on May I AI.
That is true, yeah. And we can try to use these vision transformers, or like in general any computer vision model, to be able to decide different objects are. So for example, if we follow again on the Japanese robot making omelets, it can try to use the camera to find where the eggs are, where the pan is, if the pan is in the correct place, and so on and so forth. And then what you can keep doing is, for every time step, you can say, okay, my robot hand is at this place and the pan is at that place, I need to move there. And then the robot will make the movement without using AI anymore. And then using AI in the process just makes sure to reduce the amount of damage you can make.
So going back to the Boston Dynamics robot once more, does the AI also try to find the path in between the obstacles? But the way I understand it, it looks at the image and it's like, okay, there's a rock here, there's a tree there, I need to go forward and then left and then forward again. Is that also done by the AI, that's kind of pathfinding?
Well, yes. So when we talked very previously, we talked about how there is the modern AI of deciding where everything is, and then there is the notion of symbolic AI that makes a bit more decision. Now, A-star pathfinding and other pathfinding algorithms are kind of closer to symbolic AI, and the way that it works is that the vision model will try to classify where all the objects are, and then you would represent that in a certain way that another AI can take over. And then once you have all the paths that you need to take, the control series then takes over from that and decides, okay, so I now need to move on this particular trajectory to get to where I need to go.
Okay, now this was all very abstract and also a bit removed from manufacturing. Where do we actually employ these kinds of robot in manufacturing?
Well, we can look at like a skid, for example, that works in the logistic fields, right? And then you have a pallet carrying different things, and then this skid needs to move pallets from one position to the next. Let's say a shipment is coming to take a package from somewhere, and this package is heavy, so the skid can decide, okay, this is where the package is, and this is where the package needs to go, and then the AI will take over the process.
So for me to walk once through this example, so the robot comes in, it takes a look at the package, it probably scans some sort of code, it checks up in its database, hey, does this need to go somewhere else? And then the machine learning the vision model tries to understand where this package is exactly located. It gives the command to the control theory part of it to move the robot into that direction. Then it somehow engages the pallet. Then again, the AI or the pathfinding algorithm part tries to find the optimal path to its destination, while at the same time the vision models are trying to understand if there's any obstacles, like for example a human or some kind of tree or maybe another pallet or something else. And then once it's there, it just kind of disengages and again tries to repeats the whole process.
Yes, that is true. You can also find a way to make it a bit more easier. So, for example, it could be just like any package in that red box should be moved to the white box, for example, and then the robot has less decisions to make, for example. But this is the gist of it.
Okay, if we're already at packages, where can we use AI in the logistics and supply chain?
Well, you can think about like when you have shipments and people are ordering shipments, whether it's for other companies or other factories, these shipments can get canceled or the shipment should be delayed or any problems with that. And we can use what we talked about when we were talking about slowness, where we can kind of look at the logs of how the shipment details look like, and then we can kind of predict if the shipment will be delayed or canceled. And this allows the factory or manufacturing company to prepare for that in advance.
Okay, that sounds actually very interesting and sounds like it has a really big monetary benefit to know when your shipment is late. But another thing that we also mentioned before is quality control. How can we use AI in quality control?
Well, the most basic way, let's say if you're manufacturing a certain robot and this robot works along like a path of some sort, and then you have a camera on top of it and it looks at every individual robot, right? And then we can use these vision transformers one more time or any computer vision model, and we can try to look if there is any broken robot part or if there is any things that seems out of the ordinary, an outlier, and this will be flagged for a human to take care of.
Okay, let's wrap things up. What did we talk about today?
Well, we talked about a non-exhaustive list of ways we can use AI in manufacturing. So we went over robotics, logistics, and quality control. We gave a bit of examples on every single one, and we tried to relate it to previous episodes.
Thanks a lot, Mustafa, and thank you for listening to May I AI.